Auzubillahi Bismillahirrahmanirrahim. Start with the name of Allah Almighty, who is the most beneficial and merciful. First of all, I want to say Assalamu alaikum to everyone. I hope that all of you are good and all of you are going very well in your life. So dear students, today we will discuss about the topic of the real numbers. So now we are going to discussing the calculus with analytical geometry, chapter number 1, real numbers, exercise number 1.1. In this video we will solve the first 3 important questions of this book. So first of all, we are going to discussing the first question of the calculus with analytical geometry. So in exercise number 1.1, the first question is that he says that if A comma B belongs to R, if A comma B belongs to R and A plus B which is equal to 0, prove that A which is equal to minus B. He is saying that A comma B is any real number which are belonging to set of real number and the sum of the real number which is equal to 0. So prove that the one number which is equal to the negative of second number. So this is the first question of the calculus with analytical geometry, exercise number 1.1, and now we are going to discuss this question and we are solving this question. So in a video, as we know that B is any real number which are belonging to set of real number, this is given. This is a given thing. B is any real number which are belonging to set of real number. And when B is any real number which are belonging to set of real numbers, then minus B is also belonging to set of real number. So we write B plus into minus B which is equal to 0. B plus into minus B which is equal to 0. Given A plus B which is equal to 0. So in these equations we add minus B on both sides. So when we add minus B on both sides, then this equation becomes A plus B into minus B is equal to minus B. In these equations we add the minus B on both sides, then this equation becomes A plus B plus into A minus B which is equal to minus B. Then here we write A plus into B plus into minus B, close bracket closed, which is equal to minus B. Then answer of B plus into minus B will be 0. This is given is the first thing. B plus into minus B which is equal to 0. So when A is plus with 0, then the answer will be minus B. So prove that A which is equal to minus B. So now we are going to solving the second question. So the statement of the second question is that prove that minus A into minus B which is equal to AB for all A comma B belonging to set of real number. So this thing is a given. This is a given thing, minus A into minus B which is equal to AB. So we solve these equations. Here AB is a positive sign, and when we transfer the AB into in this side, then it get a negative sign. So this equation becomes minus A into minus B minus AB which is equal to 0. Then minus A into minus B plus minus AB which is equal to 0. So minus A into minus B plus in this side we separate the minus A into B. We separate the minus A into B in the bracket. So in this whole equations we common minus A from whole equations, we take a common minus A from the whole equation. Then here minus B is only left and here plus B is left. So minus B plus B, answer will be 0. So we put the 0. When minus A is multiplied with 0, then answer will be 0. So 0 which is equal to 0. So this equation can be written as minus A into minus B minus AB which is equal to 0. Here minus AB contain a negative sign, and when we transfer it to the another side, then it gets positive sign. So this equation so proved. And now we are going to discussing about the third question. So the statement of the third question is that prove that absolute value of A minus absolute value of B absolute value less than or equal to absolute value of A minus B for every A comma B belongs to R. Here he is saying that A comma B is any real number which are belonging to set of the real numbers. So now we are going to solution of the third questions. So first of all here we take a absolute value of A, then which is equal to or less than A plus B minus B. Here we adding and subtracting the minus B. So absolute value of A less than or equal to, now we separate the A minus B absolute value and plus B's absolute value. So here B absolute value here is a positive sign, and then when we transfer it to the in this side, then it gets negative sign. So this equation becomes A absolute value minus B absolute value less than or equal to absolute value of A minus B. So now again we take absolute value of B less than or equal to B plus A minus A. Here we adding and subtracting A from the both side. So we separate the B minus A absolute value plus A absolute value. Here absolute value of A are getting positive sign, and when we transfer it to in this side, then it gets negative sign. So this equation becomes absolute value of B minus absolute value of A less than or equal to absolute value of minus B minus A. So here absolute value of when we multiplying these equations by the minus 1, or you can say that in absolute value the negative signs or positive signs may be equals. There are no further change. So we can write as absolute value of A minus absolute value of B less than or equal to minus into absolute value of A minus B. We put the negative sign, it is because in absolute value there are both values are equal, minus and plus. So this equation becomes absolute value of A minus absolute value of B less than or equal to minus absolute value of A minus B. So there are two type of equations. This is the first equation, this is the second equation, and when we compare these both equations, then we get here minus absolute value of A minus B is less than or equal to absolute value of A minus absolute value of B. We know. So in our first equations, we know absolute value of A minus absolute value of B less than or equal to absolute value of A minus B. So comparing the both equations, then we get the final equation minus absolute value of A minus B less than absolute value of A minus absolute value of B less than or equal to absolute value of A minus B. So these are both, when we open the absolute value of A minus B, then it gets two value. This is a negative value and this is a positive value. So this value is greater than this value and this value is less than this value. This is a positive value and this is a negative value. So we know that absolute value of x is equal to, or you can say that x less than or equal to x less than or equal to a, then we can write as minus a less than or equal to x, and x is greater than or equal to a. This is our equations. So we apply this terminology in this equation, and we can write as absolute value of a minus absolute value of b less than or equal to absolute value of a minus b. So proved.